Welcome to Distributed Systems course. In this lecture that we will learn about Merkle Tree. So what is Merkle Tree? So before understanding the Merkle Tree, you will look at the tree data structure and how it works. Then you will understand the Merkle Tree. So where it is used primarily, and you will learn about its applications and why it is used in distributed systems. First, let's understand a tree. Tree is a data structure which has a root node and it has a children left and right. It has a two children. Binary tree has a two children. Same way that it may have a two children. So here in the Merkle tree that we are going to talk about the binary tree. So this is a root node. It has a two child and this one is a two child. And the same way this one is a two child. So this is a tree data structure. So root node can store some data, stay in the same way that this node can store some data. Same way that all the nodes can store some data. So this is the child of this one, and each node has two children, and each node has a parent here except the root node. So why we have to use a tree? Tree has its own advantage compared to other data structure. You will see understand how Merkle tree is used here. Let's first understand why we need a Merkle tree. So here Merkle tree is mainly used in verification purpose. In distributed systems, we have multiple nodes. In distributed systems that we have multiple nodes and all of them are connected. So each node may have its own data. For example, if it is a distributed database, then each node has its own set of data. Let's consider this as a Cassandra, and whenever the client writes the data, so it may store it into the multiple nodes, for example here and here. So one copies of data is replicated into multiple machines. So we already seen in the replication section. So in case of any discrepancies, for example, let's say that we are writing some data to this node, and this one will replicate the data into multiple nodes. So due to some failure cases, due to some network partition, that it will not be able to replicate the data into this machine. Even though we already successfully transferred the data to this machine, this machine is not available due to network partition. Due to network partition, this machine is not available. So there are many cases that data that are transferred or stored in the multiple machines may not successfully done in some other machines. There may be some discrepancies across machines data. So in these cases, so how to check whether the data here are the same? We stored 100 rows here. The same 100 rows should be stored here. Since the same 100 rows should be stored here, since we have a two replication. So how do we verify the data between these machines? They are correct and there is no mismatch. So one way to do this is we can, for example, if you want to verify, we can download all the data or transfer all the data from here to here and verify it. So this is not efficient since the movement of the data across the cluster. So another approach is that Merkle tree. So what Merkle tree will do is, we will see here. Let's consider this is a file. Since here we have 100 database rows, or we can consider this is a file. So we have a two identical data. We have to verify here how this identical data is, whether it is same or whether it differs. Let's consider this is a data block. This is a data block A, this is a data block B, and this is a data block C, and this is a data block D. We are referring here ABCD as an example for understanding, but this is a data block. Let's consider this a data block. All of them are data block. So all we have to do is whether this data block is same between this machine across this machine. So how to do that? We will use Merkle tree. So these are our children. So first we will find the hash of A and hash of B. Then we will calculate hash of HA and B, which means we will calculate the hash of A and hash of B here the same way, hash of C and hash of D, the same way here, hash of CD. Then finally we have a hash of ABCD. What we've done here is that we will find the hash for each individual block. Then we will find the hash for these two hashes. The same way that we will find the hash, calculate the hash for these two blocks. Then we will calculate the hash for these two hashes. Finally, we will calculate the hash for these two hashes. Now we have calculated the hashes and hashes of hashes until we have a root hash. This is called root hash. The same way that we can calculate in this machine. So we can calculate in both machines. Instead of sending the data, we can send the hashes. For example, this tree. It has only less space compared to the entire data. So we will exchange the Merkle. So here, when we want to verify the data that is here is same, we will ask the Merkle tree. This node returns a Merkle tree. Then this node calculate the Merkle tree, compare the root hash, whether it is the same or not. If it is same, the data are identical. They are not same. For example, here instead of ABC here D here, there is some difference D1. So the data block, meaning the hash for that D1 will change. So this one will change. Finally, this one will change. So if there is any difference, then we can check the child hashes. In this case, this one is equal and this one is not equal. It differs. So we can verify the differences, and accordingly, then we can exchange the data. So instead of sending the entire data and comparing that, we are calculating the tree hashes is called hash tree, and then we are sending the hash tree to other nodes. Then we will compare the hash tree of both data. In this way, that we can verify the verify the data whether that is identical or if it is altered. This is used in variety of cases. For example, it is used in Cassandra, DynamoDB, and it is used in Bitcoin to verify the transaction block, whether there is any alteration in the transaction. So whether the block is tampered or not. So in this way that we can verify whether the data is identical, whether the data is not altered. So this is how the Merkle tree is used in distributed systems. So it is widely used to verify the integrity or authenticity of the data. So we can verify it using the Merkle tree. So instead of instead of transferring the data block, so we are calculating the Merkle tree. Once it is computed, then we can use the Merkle tree to verify the data that is stored on the other machines. In this way that we can minimize the data transfer. So this is how the Merkle tree works.